Okay, then we discuss on the application in foundation design. Okay, this if you look on EC7, it is under section number 7. Okay, so under section number 7, so we have pile load test as a loaded pile, okay, which is ULS compressive or tensile resistant to get the bearing capacity, vertical displacement of pile foundation, stability of the supported structure, transversely loaded pile, structural design of pile. Okay. So consideration taken need to take into account the action due to the ground displacement. Okay, down drag if transverse load. Okay, the design value of the strength and stiffness of the moving ground should usually be upper value. Okay, the ground displacement is treated as an incline as an action and an interaction analysis is carried out, or an upper bound of the force transmitted by the ground is introduced as the design action. Okay, under the general explanation on the section 7, okay, the design should be based on one of the following approach. Okay, so either we can use the result of static load test which has been demonstrated by means of calculation or otherwise to be consistent with other relevant experience, or we can use the empirical or analytical calculation method whose validity has been demonstrated by static load test in comparable situation. Okay, the result of dynamic load test whose validity has been demonstrated by static load test in comparable situation. Okay, or the observed performance of a comparable pipe foundation provided that this approach is supported by the result of site investigation and the ground testing. Okay. So for the pilot test, we call it as a should be carried out when using a type of pile of installation method for which there is no comparable experience. Okay, when the pile has have not been tested under comparable soil and loading condition. When the pile will be subjected to loading which theory and experience do not provide sufficient confidence in the design, so the pile testing procedure should then provide loading similar to the anticipated uh, loading. Okay. So when observation during the process of installation indicate pile behavior that deviates strongly and unfavorably from the behavior anticipated on the basis of the site investigation or experience, and when additional ground investigation do not clarify the reason for this deviation. Okay, so we can use the pile load test result, okay, in our determination of the factor safety of the partial effect safety value. Okay. So this is just what introduction on the pilot test in the EC7 under section 7. Okay, so loading procedure. Okay, because at the end we can use these methods, okay, to 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 determine what will be the capacity of the pile, okay, and it rely on how many value of pilot test that we have carried out. Okay. Okay, definition of failure of load on pile. Generally, failure load is taken as the load causing ultimate failure of pile. In engineering sense, failure may have occurred long before the reading of the ultimate load, since the settlement of the structure will have exceeded the tolerable limit. Okay. Allowable loads on pile would be one which would enable engineer to predict load settlement relationship up to the point of failure for any given type of pile of any type of size of pile in any sort or rock condition. In most cases, the procedure is calculated the ultimate bearing of the isolated pile and to divide this value by a safety factor which experience shown will limit the settlement and the working load to a value which is tolerable to the structure designer. Okay. So this is definition of the pile and why this is the design philosophy. The design of pile should comply with the following requirements throughout their service life. There should be adequate safety against ultimate limit state failure of the ground. The factor safety depends on the importance of the structure, consequence of the failure, reliability, adequacy of information on ground condition, sensitivity of the structure, nature of the loading, local experience, design methodology, number of representative preliminary pile load tests. There should be adequate margin against excessive pile movement, which would impair the ultimate serviceability limits of the structure. So that is for the design philosophy. Okay, so then we move on the pile analysis based from the EC7. Okay. So similar with the shallow foundation, we have a direct method, okay, which is from the calculation. Okay, and then we have an indirect. I'm sure there will be an indirect as well. Okay, where we use the result from the field. Okay, so for the direct method, for axial loaded pile and anchor, so the same procedure where we have combination of one and combination of two. Okay. So when M2 is for calculating any unfavorable action such as negative skin or transverse load. Okay. So this is the partial factor safety. Okay. For the structure and geo. Okay. So for the pile. Okay. So we have here the same with the action, okay, and also the soil and the type of the pile, which is driven pile, pour pile, or CFE pile. Okay. CFE pile, continuous flight auger pile. Okay. So the different type of installations. Okay, for a driven pile, they use a hammer, bore pile, they bore first and then they put the kitch and then pour the concrete. Okay, while CFA, they use like a screw, okay, and auger to install the pile. So due to the different type of installation, so they divide into different type of category. Okay. So for the R4, they mentioned here without explicit verification of SLS. Okay, so if we are not do any, for example, monitoring on the service limit or calculation on the service limit, so we may use the R4. Okay, and if you do any calculation for the SLS, so we need to use the R4 for this section. Okay. Okay, recommended value for partial factor safety, negative skin friction. Okay, so for approach number 1, okay, shear strength parameter, I guess there will be no different, okay, for the for the for the uh, number one, okay, except for the uh, design approach combination number two, okay, uh, where for the uh, sorry, oh no different on the permanent structure action, okay. For the negatives, for the shear strength parameter, for the M1, no difference, okay. For the M2, okay, the difference will be asterisk the guide recommended that about exhibit as partial action, not a material because without because okay. So there are asterisk there, okay, for the material shear strength parameter, okay, which is 1.25. Okay, while for the compressive resistance, positive skin for the R1, okay, the value is gamma S. Okay, the value is same, okay, but for the R4, the range is from 1.2, 1.65 or 1.43 for the um, gamma S. Okay, honestly, I also not familiar for this negative skin friction for the PFOS. Okay. Okay, so general equation for axial loaded single pile. Okay, so this is the common uh, equation where we have a shaft skin friction and we have an end bearing. Okay, so this is should be QB, not Q, not QP. Let me try to change it first. Okay, so that is for the QS and QB. Okay, so then we have a gamma S. Okay, for skin, partial factor for base. Okay, and then or we can use the total. Okay, uh, to get the total without differentiate between the skin and the base. Okay, okay, wait a minute. I have a call. Okay, so this is the formula for the pile under skin and bearing. Okay, so and bearing in undrain. Okay, so undrain we as we have discussed previously, it is on uh, sand. Sorry, clay material. Okay, because when the previous discussion, they differentiate between sand and clay. So for this, this is under the clay. Okay. So for pile in undrained condition, where phi is equal to 0, so this is the formula. Okay. However, okay, for LD greater than 5, SC based on skeleton, just give you, okay, so there will be changes if rely on this L over D, okay, and SC over NC, SC NC, okay. So all the soil above the base level is treated as a charge, okay, where gamma Q equal to gamma V at the level of pi base. A circular pile are treated the same way as square pile for the shape factor. So SC uh, is similar with the square shape. Okay. for the circular and for also for the square. So different cases of soil layer. Okay, so it's possible to utilize various conditions to account for soil surrounding the pile. So for case A and B, the value of NCS is limited to SC and NC equal to 9 can be found from the Scanton, from the pre-Scanton correlation. For case C, SC and NC to be taken from after. Okay, for case D and E use. Okay, so this is additional information on the case of soil layer. Okay. But for I guess for the example, we may look on the single type layer of soil only. Okay? So this is I'm not sure. This is on a multi-layer type of soil. Okay. Okay. Then this is explanation on the CAKC. Okay. Where the value will be little bit different for the NC and SC. Okay. Well, this is for the case number, case D and case E. Okay. To get the FZ in the equation. Okay. So this is for drain condition. Okay. So in drain, soil base resistance can be simplified into QB. Okay. So this is for N bearing. Okay, for the sand. So NQ is given by NQ. Okay. Either we want to use this what we call as this diagram. Okay, based on the Berzancev equation, Berzancev approach, where they differentiate between LP over D naught, which is 5, 20, and 70, or we can use just the equation on the NQ. Okay. LP is the length, D is the diameter. Okay. So for skin resistant in undrained soil, this is for the clay soil. So we have three type of method: alpha, gamma, and beta. Okay, for the Fs is equal to alpha Cu should be limited to 150 kilonewton per meter square. So then for the alpha approach, okay, so this is the equation or the value of alpha should be used. It depends on the what we call as the strength of the soil. If less than 25, so we use alpha equal to 1. It's great if within 25 to 75, so then we use the alpha of this equation. Okay. And for the alpha 0.5, we may use when the SU is greater than 75. Then we may multiply with the CU to get the FS. So this is the alpha for driven part in undrained. Okay. So this is also the alpha to determine based on the undrained shear strength. Okay. Then for the lambda approach, okay, so this is the method or the equation should be used to determine the QS for the based on the lambda. Okay. So for the beta for the undrained, based on the type of the of the soil, normally or over consolidated. Okay, where the beta in here rely on the normally or over consolidated clay. Okay. So that is the value of the beta based on this graph. Okay. So beta for seed and clay. So this is the value. So this is for the what we call as for the sand. Okay. So actually a similar approach with the conventional way. Okay. I just repeat again the formula that for skin resistant and bearing. Okay. So for the bhopal K, we have a different type of the K value. Okay. Effective vertical stress and tangent delta. Okay, so they miss here FS. So pile perimeter, pile length, FS, unit friction. FS can be expressed here. So that is the FS. FS will be constant at the conservative estimate. Okay. So need to limit to 15D only. Okay. So that is it also it depends on the on on this on the stiffness of the soil. So normally we use the average of 15D. So okay, the alpha method is used to estimate the short-term pile load capacity in fine grain. The beta method is used to estimate the short-term and long-term pile capacity in the coarse grain and long-term pile capacity in the fine grain. The actual value for alpha, beta, and NQ is uncertain. The limiting value give are not theoretical limits but are based on experience on certain soil deposit. They do not pertain to all situations. Okay. So that is the assumption made for the skin resistant in the drain conditions. Okay. So end bearing skin resistant using in situ data. Okay, so this is similar like the one that we have discussed based on shallow foundation. Okay, but based on shallow foundation, we rely on the SPT and CPT. Okay. So due to the difficulty in obtaining accurate value of the required parameter, empirical correlation based on the result of pile loading test and in situ test are commonly used to provide alternative solutions. Okay. So I guess similar with the uh, SPT and also CPT. Okay, for the pile. Okay, so to get the value for the end bearing. Okay, so we can use the corrected end value. Okay, from the ends SPT, and also for the shaft, so we can use also the corrected end value for the SP from the SPT. So for the CPT, this is the formula for the CPT. Okay. And this is the value that we can use to be included in the uh, in this equation. Okay, for example, for the CB is the soil dependent constant. So from here we can get the CB from the displacement value. Okay, so same goes with the CCPT. CCPT. Actually, for me, it's more easy to use this SPT value because the result that we obtain at the site, okay, is more uh, rely on the SPT. Okay, So we can use this value to estimate for the bearing capacity, for the end bearing capacity and also for the skin friction. Okay. Then we have here from the load test. Okay. From the load test, okay. If we have series of load tests, so we can get the RK value, okay, ultimate compressive resistance from static load test. Okay, so we need to determine what is the R min and divide with this coefficients, and also what will be the R minimum. Okay, R min is the average, R min is the minimum value. Okay, so then we choose which one is the minimum. Okay, but what we call this mean, and I'm not sure what is the symbol of this one. Okay, so this coefficient mean and mean, okay, is based on the number of the test file that we have. Okay, so we look on the number of test file, for example. So this is the explanation on the all the notation. Okay. Minimum, okay, the mean value calculate from resistance ground test minimum value. Okay, so then, okay, so this is the number of testing. Okay, for example, if we focus on only on the static load test, okay, uh, so um, for example, if the number of testing is only one, okay, so all the value of the mean, the average divide with 1.4, and the value of the mean divide with 1.4. So if we have more than 5, okay, so the value of the factor will be decreased, okay, from 1.4 to 1. Okay, so this is for the ground test. If you have a value for the ground test and also dynamic impact test, so this is the factor that should be used, okay, to get the value for the bearing capacity of the pile. Okay, so we have here model factor may be applied to the design value of the resistance of the effect of the action to ensure that the result of the design calculation model are either accurate or on safe side. Okay, so the model factor will be applied later on. Or that is we call as zeta. This is zeta. This we call as zeta. Okay, so once we have the result, okay, for example for the R, what we call RD, RD, okay, RK, so RK, then we need to divide with the model factor. Okay, so the model factor will be used, okay, to get the value for the uh, for the for the R RD later on. So, okay, the value of the model factor should be 1.4, except that it may be reduced to 1.2 if the resistance is verified by the maintained load test taken to the calculated unfactored ultimate resistance. Okay, so that is the value range from 1.4 to 1.2 to 1.4. Okay, so pile groups. Okay, 5 groups two failure mechanism should be account compressive resistance failure of the pipe and the soil contained between them acting as a block. I guess similar from what we've learned from the conventional approach. Okay, so pipe intention, okay, put out, so nothing different except for the what we call for the for the coefficient. So conclusion, designing pi foundation with Eurocode 7, important of static and pi load test. Okay. And innovative approach to pi capacity taking account of a number of load tests of or number of soil profile, need of assessing serviceability of structure through displacement calculations. Okay. So that's all for the EC7 section 7 for the PAL foundation. So we try to look on an example based on the Smith reference book. Stop sharing. Okay. So for the PAL foundation, so you need to look again on the PAL foundation. So very good to read and easy to understand. Okay, under this Smith explanation. Profile, profile, large diameter profile. Okay, so this is maintain load test. Okay, determination of bearing capacity of pipe by some by using a direct method. Okay, QU, QV. Okay. So this is based on the alpha approach. Okay, so this is on the considered soil. Or in the EC7, we refer to the what we call as to the drain. Okay, material, angle of shearing system. So this is for the shaft or skin friction. Okay, so this example based on the indirect or CPT or SPT. Okay, so we can look on the example. Negative skin friction. Okay, okay, design file to Eurocode 7. Okay, so this is based on the static where we need to use the zeta for the maintain load test. Okay, then we apply the model factor later on. Okay, so same with the one that I have discussed. Okay. Combination number 1, combination number 2. Pi incompression. Okay, partially. Okay, so this is the what we call the coefficient. Sorry, the partial factor safety based on different type of installation. Okay. So this is example for a series of static load. Okay, as we have discussed previously. Okay, we have four number of testing. Okay, so we need to look on the zeta. On the zeta, so you need to look on the zeta. So if 4, so mean should be divided with 1.1 zeta 1 and mean. So mean same pronunciation, mean and mean. Okay. And mean should be divided with zeta 2, which is 1.0. Okay. So the mean is the average 396 and the mean value is the minimum value 365. Okay. So when we divide it, so we obtain 360 is the minimum value. Okay. So since the ratio of base resistance to shaft resistance is 3 to 1, okay. So then this is the ratio has been discussed here. Okay. So mean that 3 is 3 to 1 means that the total is 4. Okay. So 75% came from the base and 25% came from the shaft resistance. Okay, so then, so then 270 is from the base, to 90 is from the shaft. Okay. So by using the design approach number 1, okay, so we need to look on the what we call it, on the table for the pile, the full table of the pile from the slide is on slide number, okay, slide number 7, slide number 8. Okay, so uh the gamma t, okay, this is based on what type of pile? Ball pile. Okay, ball pile. So we need to look on the ball pile. Okay, so gamma t, okay, look on, we need to look, okay, gamma t ball pile. Okay, total. Okay, okay, I just noticed that the difference between the MS standard, okay, with the EN7, okay, for the R1, for the R1, for the ball pile, the combined, the total gamma T, okay, in the nation standard, they use 1.00, while for the R1, in this example, they use 1.15. Okay, so you can highlight in your slide, okay, there are different of the R1 in the total or combined. Okay, so they use 1.15. Okay, so 313, okay, while using the combine. Okay, so or we differentiate between the base and the skin. Okay, the value is 1.25, okay, and 1.0, 1.25 base. Okay, base for the ball pile. But in the Malaysian standard, the base is 1, okay, the shaft is same. Okay, so that's the difference for the ball pile for the Malaysian standard. Okay, so I'm not sure why they have that kind of difference. Okay, so that is 1.25 and 1.0. So the value is 306. Okay, by using the total and by using the base and shaft. Okay, so then design approach number 2. Okay, partial factors R4. Okay, so R4 for the ball pile is 1.5. R4 for the ball pile. Okay, R4 for the ball part is 1.5. Okay, and the rest is 1.6 and 1.3. Okay, so the value is 238. Okay, so then the design composition of the ground is just determined as, so this is the value 313, 306, 240, and 238. So later on, the RCD that we use is 238. Okay. So that is how we calculate the capacity based on the static load test. So that is the RCD. Okay. So the ultimate compressive resistance from the ground test. Okay. So ground test here has been discussed. Okay. So I guess almost similar with what has been discussed in the static. Okay. So this is the result for the ground test. skip this one because almost similar with the one that we have discussed previously. So, but we need to refer to the zeta 1.3 and zeta 1.2, zeta 3 and zeta 4. Where is zeta 3, zeta 4? Okay, so, but they only provide for zeta 1 and zeta 2. Not in here, they provide the zeta 3, might be in different chapter. In different chapter. In table 8.8, where is table 8? They are not means, they are not. Okay, here. Okay, oh, that is for zeta 1, zeta 4, okay. Zeta 3, zeta 4. Zeta 3, zeta 4. Okay, then they calculate for the zeta 4. Okay, so design approach similar because this is a Bhopal. Okay. Okay. Sorry, this is Bhopal or what? Ribbon pile or Bhopal? Or CFA. So CFA pile. So we need to refer to CFA. Okay, CFA. So this is CFA. A little bit different with the one that we've discussed in the slide. For the R4, they have a with without explicit verification of SLS, with explicit verification of SLS. So, but for this case, there are no differentiate between R4. Either we include or not include the SLS. Okay. Okay. Ultimate capacity resistance. Okay. From dynamic or the static loads are most common. The resistance can be estimated from dynamic test, provided the test procedure can be calibrated. Again, static load test. Okay. So this is the procedure for the by using the ground test using the CPT. So then for the action pi group, action of pi group, settlement effect. Okay, okay, this is just exercise. So they doesn't provide the example for the uh, what we call for the calculation for the single file. Okay. Okay, let me share with you an example. Okay, from yeah, again from Prof. Ramli. This, and this will be the last example. Okay, I will share with you in the slide, in the e-learning letter. Okay, let me find first. Okay, so I have complete discuss on the Smith. Okay, example. Then I will try to get one example from Prof. Ramli. Okay. Stop. Okay. Okay. So a concrete pile with 16 meter in length and 410 millimeter square in cross section. Okay, the pile is fully embedded in sand. Okay, for which gamma is equal to 17, P is equal to 13. Calculate the design point loads. Okay, so this is the formula. Okay, design 1.2, design approach 1 and 2 will be more practical since only resistance involved. So
Doctor,
this
can you
huh?
make the
Larger.
zoom for
Okay. Wait. Okay. So a concrete pile of 16 meter in length with 400 feet. Okay. So design approach combination 2 will be more appropriate since only resistance involved. Okay, so this is what has been because um M1 sorry actually this is should be M2 not M1 R4 okay R4 so this is should be M2 not M1 because we are using the approach the combination number 2 okay so A2 M2 R4 okay so Prof Ramli just use the approach number 2 combination number 2 straightforward okay because this is um, okay, so the value of the fee is 30. Okay, so then the same procedure, get the uh, fee value. Okay, uh, when we divide with 1. Okay, okay. Sorry, for this case, probably. Oh, okay, we go through first. I'm not sure why they have some uh, error here. Okay, so A2 if we are using M2, so the the fee D should not divide with 1. It should divide with 1.25. Okay, or we just follow A2, M1, and R4, and then I will get later why he used M1. Okay, so for example, if you use a combination number 2, so normally we may use the M2, not M1. Okay, so I will clarify with Program D. Okay, so 30, then 30 divide with 1. So then we calculate for the NQ equal to 18.39. Okay, so for the gamma B, okay, gamma B, when we look on the R4, okay, so the gamma B is equal to 1.87. Okay, so we calculate first for the RB, okay, which is the end bearing. So the value is 840 times 8. Okay. So then this 840.8 divide with the what we call it with the 1.87 and then multiply with the model factor which is 1.4. Okay. So then we obtain 321.16. Okay, so that is for the RB of the base. Okay. Okay. So for the skin resistant, okay, given Ks is equal 1.3, okay, then the friction between friction between pile and soil is 0.8 phi. Okay, determine the design frictional resistance RSD. Okay, so then tangent uh, tangent sigma d is equal to 0.445. Okay, so design approach 1 to 2 will be more appropriate since only resistance involved. So A2, M1, and R4. Okay, so then we calculate first for the skin resistance 1.3 times 18 times 17. Okay, 16 is the unit weight times with the 17. Let me check 17. 16, sorry, 16 is the what we call is the length. 17 is the unit width. Okay, times 0.0445. Okay, we should RPT. Okay, so 0.05 times 0.41 times 4 times 16. Okay, so actually, we should have the limiting value, which is 15D. Okay, 15D should be applied in order to um, make sure that it is not overestimate the resistance. But I will clarify with probably. Okay. So then the value is 4128.9. Okay. So later on the 1.65, okay, based on the shaft compression times with 1.4, then we obtain 1787.4. So the total value, okay, which is the reaction 231.16 plus with the skin 2108.6, so we obtain 2100 kilo Newton. Okay, so for a permanent unvariable action for DA1Q is the maximum value allowable kinetic load that can be carried out by. Okay, okay, so that's why he used 1 instead of use 1.2 1.25, if I'm not mistaken. Okay, so that's why he used the M1, not use the M2. Okay, so he just want to make sure that the value is greater. Okay, so that is the maximum. Or we can still check for the both. Means that we check for the combination number 1, and then we check for the combination number 2, and then confirm which one is the maximum value. Okay. Okay. So I will share this example in the e-learning. Okay, and there will be several example. Okay, but I'm not discuss in during the class. So you can go through for the example. For example, this is negative skin friction. Okay. And example on group pi design. Okay, so you can go through. So if you have any problem, so please let me know, because we have a limited of time. So I plan to finish by before 1. Okay, so I will put in the what we call in the e-learning. Okay, okay, so I guess that's all for the deep foundations. Okay. And okay, I will discuss this probably. Okay, and then let you know, especially on why he not multiply with the 15D. Okay, and then why he only choose M1. I guess is the answer is here. Okay, but I need to confirm with him. Okay, so I guess that's all for today class. Okay, so
So is there any assignment?
yeah, I will share with the assignment by tomorrow or on Tuesday. Okay, because the assignment should be similar with the Perdana class as well. Okay, so that's all for today. We upload the video and also the additional example in the e-learning.